Hi, I'm Josh Lovell, Business Development Manager for Teledyne Labs Pharmaceutical R&D Products. Thanks for joining our regular webinar series. Today we will switch gears with a focus on our evaporation products partnering with EcoDist. The title for today's talk is Don't Accept the Status Quo, Overcoming Pain Points in the rotavap Process. As a reminder, if you have any audio-video issues, please exit the webinar and rejoin. This usually resolves the issue. If you have any questions during the webinar, please type them into the questions box. Some questions will be answered at the end of the webinar, while others will be followed up with after the webinar. The webinar will be recorded and made available for future viewing. This presentation today represents an expansion of the types of products offered by Teledyne Labs to our loyal user base. This opportunity is the product of our partnership with EcoDist to offer a value-added and unique evaporation solution to our customers that is found immediately before and after the preparative chromatography workflow. Today, I'm honored to introduce my friend and founder of EcoDist, George Ajabang. George is a multifaceted scientist, entrepreneur, engineer, inventor, and discoverer of the cancer drug Tafinlar. Luckily for all of us, he has also designed and produced and launched the EcoChill scientific instruments in 2015. Like many of you, George's background is medicinal chemistry, providing an inspiration to develop new solutions useful for chemists. George, thanks for joining us today to share the EcoDist story.
Thank you, Josh, for the kind words and introduction. Yes, the partnership between EcoDist and Teledyne is one that has a lot of benefit for customers. Purification and evaporation go hand in hand. So this brings a lot of benefits to our customers. And in today's webinar, the agenda will cover about 4 main areas. And so today we'll tell how EcoDist dramatically improved upon traditional evaporation challenges. One, the bottleneck of condensation and cooling capacity using traditional cooling techniques. The limitation of glass coil condensers in the evaporation process. The unnecessary cost of inefficient, incomplete condensation of vapor, and we'll touch on the pitfalls of common rotary evaporators and the hidden costs of the customary external cooling burdens. Don't accept the status quo. Overcoming pain points in the rotary evaporator process. A journey to a better rotavap. What is a rotavap? A rotary evaporator or a rotavap is a device used in chemical laboratories for the efficient and gentle removal of solvents from samples by evaporation. And this is often done through heating and cooling. Meet me, George Ajabang. I am the founder of EcoDist. Myself, having used rotary evaporators for well over 15 years, right from college through graduate research in organic chemistry, and then subsequently as a scientist or chemist in Big Pharma, where I used rotary evaporators extensively during drug discovery as a medicinal chemist. In my experience with traditional rotavaps, the cooling process was slow, costly, unreliable, and inefficient. And this is generally the case for all the types of traditional rotavaps on the market. And we can put them in 3 categories based on the condenser type. That is tap water condenser, dry ice condenser, or chiller condenser. And all these three methods have their own limitations or inefficiencies associated with them that makes the process quite slow. Tap water, you're looking at the cost of water. Dry ice is supply chain issues and cost of dry ice. Chiller is inefficient and energy consumption. And this is some of the issues that are associated with any of these types of rotavapes out there on the market. So I grew frustrated with traditional rotavapes and started probing and asking questions, and led to the idea that there got to be a better way other than what we have on the market. So that led us to what EcoDis now has brought to the market. So I invented and patented a better solution that is easier and more convenient to use, gives faster evaporation, is eco-friendly, and uses no consumables. That is no antifreeze, dry ice, or water required for the condenser. This device also removes solvents from samples more efficiently. It is also reliable, very energy efficient, and above all, it's a sustainable solution. And it's compatible with almost any chemical or solvent that you will encounter in the lab. So here comes the other way. We've talked about the traditional rotovalves, their cooling methods, the three that I talked about earlier. That is water, antifreeze, dry ice, and in some cases, liquid nitrogen. And so, as you can see, all these traditional rotovalves on the market require some form of material. So there is material waste, either water, liquid nitrogen, dry ice, or antifreeze. And contrast that with the EcoDis rotary evaporators, which have no material required. That is zero material waste. And the cooling is done directly, what we call self-cooling condensers, by utilizing refrigeration technology to directly cool the coils. And thereby, we have eliminated all these materials that are used in traditional rotovapes. A better rotovap, one will ask, and don't take my word for it, but here is a testimonial from one of the world's renowned scientists or organic chemistry uh, professors, Professor Joe DeSimon. And he acknowledged that, yeah, the rotovap is an indispensable tool in labs. However, currently marketed systems are suboptimal, both with respect to the amount of time required for the system to cool down and for the need to waste dry ice or water to keep the apparatus cooled or chilled. So as you know, I am a strong proponent of green chemistry. That's Joe saying this, not me. So EcoDis' unique solution to these two problems is naturally attractive. I'm excited that the EcoDis design does not require a source of water or dry ice, eliminating the major source of material waste associated with rotovapes. And as I can tell you, his labs are one of customers or some of his labs use our products, both in industry and in academia. Here are two of our leading rotary evaporators. These are the all-in-one benchtop units, termed hydrogen. And the name hydrogen is just the brand name for this equipment. Not that they generate hydrogen or use hydrogen, just the brand name. Coming from the idea that this equipment don't require any external materials like the dry ice, water, and the freeze we spoke about earlier. And here are two models, the 1H performance and the 1H hydrogen. And the main difference is in the user interface and vacuum controller. The 1H hydrogen on the right is an LCD screen and no built-in vacuum controller. So it requires a vacuum and a vacuum controller. Whereas the 1H performance on the left has a touch screen and built-in vacuum controller. So the only equipment to add to it is a vacuum pump. Here is a video of the 1H performance, specifically showing the touch screen, the built-in vacuum controller. You can control the vacuum, you can control the rotation, the heating, the cooling. It also has, methods can be saved. You can have your favorite methods. The lift is automated. You can see how easy and convenient it is to use it. Don't accept the status quo. So the next topic to cover is overcoming pain points in the rotavap process. That is, I'm going to delve into the existing chilling techniques for evaporation. Disadvantages of current rotavap chilling techniques. And on this slide, I'm showing the water-chilled condenser. And one of the challenges with water is it can only get as cold as what the tap water is producing. And so as a result of that, we have very poor cooling power. And water does not reach the temperatures as cold as other technologies. Limit cooling capacity and inefficiency in the lab. Often, if you evaporate in volatile solvents, water condensers cannot efficiently condense those vapors. So it creates a safety hazard as vapors may not condense at the temperature of the water running through the condenser. And this creates hazard in the lab for both the users and equipment as vapor is released into the environment, surrounding environment, and equipment as well. And then also to tag on to that, talking about the cost and waste. We're wasting a lot of water, and there was a study that came out of Boston that was done by Thermo Fisher many years ago that estimated the use of water condensers per machine to run about $7,000 a year. So for universities or colleges that are still using water thinking water is cheap, it's actually not that cheap for those who are footing the water bill. Disadvantages of current rotavap chilling techniques. Dry ice condenser. One, inefficient and costly. It requires babysitting as scientists are required to monitor and refill dry ice machine. Can be left unattended due to risks of incomplete condensation and running dry. 2. Cost of dry ice, estimated to cost about $3,000 to $5,000 per year per machine. Supply chain interruptions quickly translates into productivity downtime. The other disadvantage is safety. Inefficient vapor trapping leads to toxic fume hoods escaping into the lab. Safety concerns of using glass condenser with dry ice due to drastic temperature changes, often resulting in explosion of the glass. And 3, unreliable, unsustainable, and wasteful. Energy and transportation cost of making dry ice and pollution associated with transportation, and frequent downtimes due to rapid evaporation. About 70% of dry ice is wasted through escape. Disadvantages of current rotavap chilling techniques. Now we are on the recirculating laboratory chillers. And one disadvantage is poor cooling power. It's not on demand, slow to reach operational state, and quickly loses cooling power. Not energy efficient, noisy, and slow to cool down, and unable to sustain cooling. Inefficient vapor trapping, also leading to toxic fume hoods escaping into the lab. Another one is safety and sustainability. Antifreeze frequently leaks, requires changing, spills, and must be properly disposed of. Environmentally unfriendly, posing danger to both people and the environment. And third, cost and space. Cost of additional equipment, the chiller. It's also energy inefficient, so cost of energy. It takes up space and is bulky and heavy. And now move on to another pain point, and that is the problem with glass and cooling capacity. Why is glass not the best? One, existing products using a recirculating chiller use a glass called a condenser. A glass has a low thermal conductivity, so it's less efficient than stainless steel at transfer of heat from the surface of the condensing coil to the recirculating chiller. Almost 50x higher thermal conductivity than glass. Major rotavap manufacturers were focused on the wrong solution. Small incremental changes on things that did not address the major drawback of rotavaps. At some point, these two major rotavap companies were competing on who made the largest glass coil condenser. It is glass. How much more efficient can you get it? Glass is a poor conductor of heat. For example, it only transmits about half the temperature of dry ice. EcoChill condenser technology is based on using a stainless steel 316 metallic alloy that is coated with HALA, which is chemically resistant to strong mineral acids, alkalis, and organic solvents. Another thing that we want to touch on is there an on-demand chilling technology for evaporation? And I mean, with this advanced world in which we live, we expect equipment and devices to be there and available when we need them. Do we have the same thing with traditional rotavaps? So we're going to touch on that on the next slide. So yeah, the answer is no, there's no on-demand device for traditional rotavaps. Echo provide that. And here is the main difference between what is giving us that versus the traditional one. So the picture on the left is showing the recirculating chiller, two heat transfer steps. So on one side, there's the condensation rotavap glass coil that is connected to a recirculating fluid. And then you have the recirculating fluid bath to the refrigerant coil. So on one side, you're using the refrigeration technology to cool down the antifreeze or, thermal fluid. And then on the other side, you're using a pump to circulate that to the rotavap condenser coil. So these two steps then generate inefficient steps that eventually leads to inefficient rotary evaporator process, because you require a reservoir, you require an antifreeze, you require a condenser chamber for the antifreeze. It's just more complicated equipment, and so the more complexity you added, the less efficiency you achieve. Contrast that with the EcoChill system or EcoDis single heat transfer system. So basically what we have done is take the refrigeration technology and put it directly as a rotavap condenser. So in this case, you're looking at on-demand condenser where we can reach -20 in a matter of seconds, and overall gives us an efficient and powerful cooling capacity because everything is done at the point where you need to condense vapor. We are cooling the condenser coil where you want to remove heat immediately the heat touches the condenser coil. So that's that difference for on-demand technology versus something that takes time and inefficiency that builds up.
George, that's a great explanation of the time and energy required to keep a recirculating chiller at temperature and ready to use. We had some fun in the lab with a FLIR thermal camera to show how quickly the EcoChill technology goes from ambient to operating temperature. You can see that within 30 seconds, the coil is cooled to -20 degrees Celsius and ready for use. That is truly on demand, and we can save a lot of energy by not leaving it on when it's not in use. George, can you elaborate more about how the on-demand cooling technology is intelligent to control the cooling capacity to match the heat load?
This is a busy slide, but work with me here to walk you through what is happening here. But pretty cool on this intelligent and on-demand cooling capacity. And what do we mean by intelligent? Basically, the cooling capacity adapts and adjusts in real time as your evaporation needs changes. In other words, the more you evaporate, the more heat load you generate. The machine will intelligently determine that there's more heat load and it will adjust the cooling capacity to meet that demand in real time, so that you, the scientist or the user, have no need to do anything to the cooling side of your evaporation other than turn it on, and the rest will be done intelligently for you. So if you look here, again, it's showing in this picture, on one side you are heating, so you heat a liquid, which generates a heat. That heat transfers from the liquid to gas, so it's a phase change. And then we use these cooling coils to take out the heat that the gas brings from the gas. And once we remove the heat from the gas, we convert the gas back to liquid. And that heat is dumped out through the refrigeration cooling technology of the machine. So, and the only action that you are required is to turn it on. The condenser senses heat and intelligently provides the cooling necessary to remove the heat. As the heat load increases, the condenser adjusts the cooling capacity to remove more heat. Operator, there's no need to set a desired temperature. The machine does it and does it more accurately. Right? So on demand, turn it on to use, turn it off when not using. And the reason being that You don't need to even waste energy to leave it idle when not using it, because when you need it, it's ready in a matter of seconds. So we save more energy by the fact that we don't need to leave it idle when not in use. So how is this working? The heat exchange. To give an amount of heat used to convert liquid to evaporated in evaporate sorry so heat exchange, it's the amount of heat used to convert liquid in evaporating flask to vapor is the same amount of heat that the condenser removes from the vapor to convert the vapor back to liquid. And so this is just a liquid to gas to liquid phase when it comes to rotary evaporation. So our ability to use cold metallic coils to take the heat out is way more efficient than using your traditional antifreeze water or dry ice. And here is a cooling chart or cooling capacity chart of one of our units. I believe this is the benchtop unit, probably the 1H performance cooling chart. So you can see the temperature range if you're measuring in degrees Celsius from -40 all the way to -12. If it's in Fahrenheit, basically -40 is the same to 10 degrees C. And you see the BTU varying from 620 BTU all the way to 2800 BTU. And so as this machine is in use, this cooling capacity will constantly adjust to produce BTU within this range to meet the amount of vapor that is being evaporated. And this has been done in a way that the maximum vapor or flask size that you can use for evaporation for each size machine is sized accordingly to be able to adequately and efficiently remove the vapor or condensed vapor. And here is a time and energy savings chart from a white paper based on actual third-party study that was done in the United Kingdom at Oxford University. And in showing here is EcoDis hydrogen performance compared to a traditional chiller. So the chiller set temperature, of course, traditional chiller is the coldest they go is -10. So we have one EcoDis hydrogen set to -10 for that direct comparison, and then another set to -34. And you can see the pull down time took the chiller 70 minutes to achieve -10 degrees. And the hydrogen takes 1 minute, and the 1 minute basically to reach -10, and then about 5 minutes to get to -34. And the pull down energy usage, you're looking at about 225 watts versus 25 and 43 watts. Right. And so the chiller energy compared to the EcoDis, the chiller is 303 watts, EcoDis 12 watts, and 109 watts. So in all, if you look at the pull down, like in 8 hours, that's about 2.6 kilowatts compared to 0.12 kilowatts or less than 1 kilowatt. So your yearly cost for dry ice or for chiller compared to our machine, if it's 120 pounds compared to 5 pounds or 41 pounds, significantly different. And the total CO2 per year cost also enumerated here. So you can see the energy or the eco-friendliness of this equipment compared to a chiller. So one question that often comes up is, okay, we have this great on-demand chilling technology. Can you use it with your traditional evaporation setup? And the answer is yes. Shown here are two of our condenser technologies that can be used to upgrade traditional rotovapes. So we have the benchtop one, the EcoChill X1, that can be used to upgrade any benchtop rotovap up to 6 liters. It's easy to do the upgrade. Just remove the existing condenser and place the EcoChill there, and you're ready to start evaporating with our on-demand condenser technology. And similarly, this can be done on a larger scale system. So shown here is our EcoChill X3 condenser um, upgrading a traditional 20-liter rotovap. And we have these cooling systems ranging from the X3 all the way to X9. And the X9, of course, it handles our 200-liter system. So basically, if there's a traditional rotovap that is 200 liters, you could pair it with our X9. But most traditional rotovaps are 20 or 50-liter system. And in that case, we can utilize our EcoChill X3 or X5 or X7 to upgrade an existing 20 or 50-liter rotovap. And we give you plenty of reasons to switch. I'll be saving a lot of money. If you're using dry ice, then you'll be eliminating the wasteful consumption and spending for dry ice. And same thing with water. If you're using water and you replace the water condenser, you're saving right there by not wasting water. No dry ice available. That there's nothing you can do. It just slows your work down, just delays you, impacts your productivity. Dry ice shortages can impact workflow, and drive increased cost. And increase scientist efficiency. If you have an equipment, there's no need to monitor dry ice evaporation so that you can actually be evaporating whilst you're in a meeting or evaporating whilst you're doing something else. It frees you up so you can focus on more complex chemistry tasks. So get to the next synthetic step faster. On-demand chilling will have you wasting no time, either changing antifreeze or losing water. And then there's value for lab bench space. Real estate, as I said earlier, lab space is a premium. And so this equipment with small footprint maximizes your lab bench space and no need for space for external chillers that takes up a lot of premium space. And up to this point, I've shown mostly the benchtop units, and we talked a lot about all the technology can do. And often a question comes in, how about large scale? And as I showed in a few slides back, that we can upgrade some of the large scale traditional rotovers, the 20 or 50 liter. Yes, we do have large scale technology, more than what is out there traditionally. So in the next slide, I'm going to show you industrial scale or large scale evaporator technology. This slide is showing our large scale evaporators ranging from 12 liters all the way to 200 liter. And as you can see, we do have quite a few selections. The 12, what we call the EcoChill X3, comes in two sizes, 12 and 20 liter evaporator flask sizes. We have the EcoChill X5. You can see it's a single coil condenser that can also handle the 20 and 50 liter evaporator flask sizes. Then comes the middle portion of the equipment, the EcoChill X7, that has a wide range of capacities. It can handle anything from 20 liters all the way to 100-liter evaporator systems, ranging in different heat capacities from 3 kilowatts all the way to 8 kilowatts of evaporating flash. And then our biggest of them all, a 200-liter EcoChill X9. The X9 comes with 3 condenser coils that is powerful enough to handle any evaporation needs up to 200-liter capacity. This slide is showing our 50-liter EcoChill X7 high-speed evaporator compared to a traditional 50-liter rotavap. And as you can see, a traditional rotavap has a lot of glasses, a lot of glassware. That means the risks of breaking and replacing glassware and the cost is substantial. But in terms of capacity, a traditional 50-liter rotavap has about 25 liters capacity compared to our 50 liters capacity. And as I said, on the glassware side, a reduced glassware footprint provides many benefits. And so if you look at our equipment, the EcoChill X7 50-liter, we have very minimal amount of glassware. So that saves you time and money. It also gives safety for personnel, product, and property. And it increases productivity. There's less glass to break, so there's less downtime. Eliminate unnecessary downtime and maintenance. And then in addition to that, look at the energy consumption. This whole complete system is about 6 kilowatts compared to that 12 kilowatt traditional rotavap. And yet still, this EcoChill X750 liter is 3 times faster in terms of evaporation rate compared to the traditional one. So we double the capacity, half the energy, and more than triple the evaporation rate. That's a huge improvement on existing technology that will impact your lab in a real meaningful way. And this is an interesting slide, but it's a reality and it's true. 1 rotavap versus 10 rotavaps. And presented here is an EcoChill 100-liter system. So this is EcoDist 100-liter EcoChill X7 high-speed evaporator being compared to a conventional 20-liter rotavap. And we're saying, yes, you will need 10 of these 20-liter rotavap traditional ones to do what our 100-liter system will do. And the point is coming from the fact that the 20-liter rotavap has a maximum load volume of 10 liters per flask versus a 100-liter system. So if you compare them price-wise, you compare them on energy-wise, you compare them on evaporation rate-wise, hands down, we got a capacity, we have the speed and high output for this technology. And this is also reduces your labor cost and labor time. It's one equipment to operate that can deliver more than what 10 equipment will do. It's a game changer. And here are some of the value differentiators between an EcoDist large-scale evaporator and a traditional rotavap. In terms of solvent recovery, they will both evaporate solvent, but the rates are not the same. We can also easily use our cooling system with chemical reactors or process reactors. That's a very handy thing. So if you have reactors or process reactors, easily connecting an EcoChill condenser to it allows you to evaporate solvents directly from your reactor. And so our rate of evaporation, as indicated earlier, is higher compared to the traditional ones, yet we use less energy. All of these evaporators are equipped with bottom drain valve. What this bottom drain valve allows you to do is be able to drain your product without moving glassware. So There's no disassemble required for this process. You also get cleaning in process and overall very low man hours, translating into also low maintenance with cost of lifetime ownership very low. This gives you very high ROI overall. So these large scale systems will give you higher ROI compared to the traditional rotavaps. And this is what I was saying on the previous slide. Then the echo chill condensers can be used with existing reactors. So shown here on the right is actually a actual setup of EcoChill X7 with a 30-liter reactor. And since we have these EcoChill systems from X3 all the way to X9, it means we can connect them to a whole range of reactors ranging from 10-liter reactors all the way to 200-liter reactors. We have the corresponding condensers to pair with these systems that you might have in your lab, saving you a lot of time and money. So in conclusion, you can see what we've been able to do, that the bottleneck of condensation and cooling capacity using traditional cooling techniques has been eliminated or addressed using our new technology. We also talked about the limitations of glass core condensers and recirculating chillers in the evaporation process. We touched on the unnecessary cost of inefficient, incomplete condensation of vapor. Remember the case where you have toxic fumes escaping into the lab or environment of pumps. And also touch on some of the pitfalls of common rotary evaporators and the heating cost of the customary external cooling burdens. Some things like, the cost when dry ice is not available, heating cost when a pipe bursts in the lab because tap water connected to rotavap can break, or antifreeze pipe bursting and flooding the lab with antifreeze. And we touched on how you can take your evaporation to the next level by maximizing the cooling capacity of your evaporation equipment. In other words, not only do we have the whole complete systems of evaporation technology, but we also have the condenser technology that can upgrade an existing rotavap to allow you to take advantage of our on-demand condenser technology. I hope you've enjoyed this webinar and learned a lot from it. Thank you.
George, thanks for the informative presentation. At this time, we'd like to open the floor to questions. As a reminder, if you have any questions, please type them into the questions box. We'll answer a few questions here to end the webinar, and we'll follow up with any unanswered questions after the webinar. Okay, George, here's the first question. I understand the advantages of the on-demand nature of the cooling that the EcoDist offers versus other techniques, but how does the rate of evaporation compare to traditional rotovaps? How much time can I save?
The rate of evaporation is 2 to 4 times more than traditional rotavaps for the benchtop to large-scale systems.
George, thanks for the answer. It's important to realize how cooling capacity plays a role in the speed of evaporation, and it's often an overlooked limiting process. Another great question from the audience. What is the condenser coil made of, and what is its compatibility with chemicals?
The condenser coil is made of 316 stainless steel coated with a chemical-resistant Hela polymer, resistant to organic solvents, acids, and alkali.
George, it's good to know how robust the halar coating is and how it can stand up to different solvents, including organic acids, strong bases, and various organic solvents. We're running out of time and have one last question we can address today. Do any of the models have built-in vacuum pumps?
No, there are no built-in vacuum pump models. All models use external vacuum pump. External vacuum pump allows for a wide selection of vacuum pumps for specific applications.
George, thanks for the wonderful talk. As a reminder, please follow us on your favorite social media platform to stay up to date on the latest products, applications, content, and specials. Special thanks again to George for joining us today to share his expertise about evaporators and the challenges that he faced as a medicinal chemist and that EcoDisc now solves. Thanks to the audience for joining us today. We look forward to you joining us on our next webinar.